Alright, so let's build off our x squared plus 4x plus 4 example and look at a similar problem where we don't have quite enough tiles. We have an x squared term, 4x's again, so I split up my 2 x's on each side, and I have 2 unit tiles. But I want to make a perfect square, right? I want to make this easier for me to solve. Well, I can choose to add on 2 squares, but then I have to remember to take away those 2 squares at some point, because I can't just magically add on 2 units to an equation. So instead, what I could do is add on 2 squares. You can see that here in our equation. I'm adding on 2 units, and I'm also taking away 2 units. So I'm really just adding by 0. So how does that change my equation now? Well, I have x squared plus 4x stays the same. 2 plus 2, I'll have 4 minus 2. Oh wait, this looks pretty familiar. X squared plus 4x plus 4 is equivalent to x plus 2 squared, and we still have our minus 2 here, is equal to 0. If we continue, we're attempting to solve the value of x, right? So let's isolate our variable by adding 2 to both sides, leaving us with x plus 2 squared is equal to 2. And again, we'll take the square root of both sides. We really have to remember that there's actually 2 possibilities, a positive and a negative answer to the square root. And from there, we can go ahead and solve the values for x when the square root comes out positive and when the square root comes out negative. And here are our 2 solutions that we found.